Hey algebra students, welcome to one of our last, if not the last video for the year. We're looking at 512 solving polynomial equations. And just as a warm-up, we're going to factor some trinomials here. So we'd like you to factor your warm-up trinomials, pause the video, and then check in. Okay, so hopefully for this first one, you're using your trial and error, and you need factors of 6 and 2 broken down into their factors that will add to 13, and that's going to give you 6u plus 1 and 1u plus 2, and hopefully that's what you got. If you have questions about that, make sure you're asking your algebra teacher. And for the second warm-up, hopefully you were able to break that down into 7b minus 3a and 1b, or just b minus 2a. Again, if you're struggling with that, you want to make sure you see your algebra teacher, either ask questions in class or come to RAM for that. And you can also, of course, make sure that you can do your foiling or multiplying every piece by every piece back to get to the original trinomial. Okay, so now hopefully that your kind of heads are in the space of factoring, we're going to take a look at how to solve polynomial equations after they're factored. And in order to do that, we need the zero product property. Again, zero product property. And, you know, that sounds fancy, but really all that's saying is for all real numbers, a times b equals 0. If, looks, we have extra f there, if and only if a equals 0 or b equals 0. So it just means when you're multiplying and getting a product of 0, that one of the factors is 0. And that's a rule you probably already knew. But we're going to use this when we're solving polynomial equations. So because I know some of you are super organized and you like a list of how to do things, so we're going to start with the solving method there. We want to get all the terms onto one side equaling 0 on the other side. And we do want to put them in descending order, and that's what we're used to factoring in. Then we want to factor, and just the kind of the double bubble there, or the, you know, two sets of parentheses. And then we set each bubble, we set each set of parentheses equal to 0. Now what this alludes to is that zero product property, where if those factors, their product is 0, then one of those factors must be equal to 0. Then we solve each equation, and then we put our answers into a solution set. And just as a reminder, that's the solution set. So in our first example, we have that trinomial y squared minus 5y minus 36 is equal to 0. And it's going to look a lot like factoring, because that's what we're doing. We're just taking it one step further. So when you're looking at that and you have that first coefficient of just 1, then you're looking at factors of negative 36 that will add up to negative 5. So kind of thinking about how to factor that. So as we write that down to kind of do our work, we basically just want to do what we've been doing with factoring. So there's that kind of double bubble, so to speak. And we want factors of negative 36 that will add up to negative 5. Because that, I'm just going to point some things out along the way for some of you still struggling with factoring. Because that's third term there is negative, that tells you that the signs inside your factors are going to be alternating. So when that's negative, we have alternating factors. Now the first term here with a coefficient of 1, so that's just going to give us y times y. Now we need those factors of negative 36 that will add up to negative 5. So you want to think through your factors. The other thing I want to point out is because that 5 is negative, then that means that the higher factor is going to be the negative factor. So just keeping that in mind as a rule as well. And so we're going to break it 36 down into, or negative 36 down into that negative 9 and a positive 4. Again, the 9 being the higher of the two values. We want that to go with the minus or the negative because of the negative with the 5 for the middle term. Once you have that factored, then we set each factor equal to 0 in an equation, because if this product is 0, then one of those factors must be 0. So y plus 4 has to equal 0, or y minus 9 has to equal 0. And so y must be equal to negative 4, or y is equal to 9. And then we just take our solutions and put them into our fancy little solution set, and we get negative 4 and 9 for our solution set. Don't forget that you can check your answers with FOIL, that you can kind of put things back in and make sure it's equal on both sides. All right, so this one's a your turn. You want factors of 18 that will add up to negative 11. So again, you're setting that up to be factored, so 0 is equal to, and you're looking for that kind of double bubble. Since we have a coefficient of 1 in the front there with the p squared. Little hint that your third term there has a positive or a plus, which means that the factors will have matching signs or matching operations. And because the middle term is a minus, those matching operations should be minus or a negative. So give that a shot, and we'll ask for your answer on Edpuzzle, and then we'll check in. All right, so your factors should have come out to p minus 2 and p minus 9, and then you set each of those equal to 0. So p minus 2 is equal to 0, or p minus 9 is equal to 0. And so p should be equal to 2, or p is equal to 9, and your solution set is 2 and 9. So just looking in example 2 at another kind of example where this is factored already, and this actually just saves you some time. It's really not a different method, that we see that this product equals 0, and so one of those factors must equal 0, so we can go right to setting them equal to 0. So 2x minus 3 has to equal 0, or x plus 5 has to equal 0, and we solve our equation there. And so x is equal to 3 halves, or x is equal to negative 5. And again, we do want to make sure we're indicating a solution set. I'm going to try and put my solution sets in order from least to greatest. So negative 5 and 3 halves belongs in that solution set. So for the next your turn, again, we'd love for you to pause the video and check it out. You should notice that this one is a little bit different. You've got 3 factors set equal to 0. So again, one of those factors has to be 0. But you should have 3 equations that you're setting up. So again, pause the video, see what you get, and then check back in, please. Okay, so you should have set 6b is equal to 0, or b plus 5 is equal to 0, or, so we've got an extra here, b, oops, let's make that a b, b plus 2 is equal to 0, and we solve each of those. And so here b has to be equal to 0, or b is equal to negative 5, or b is equal to negative 2. And we want our solution set, and we want to put those in rank order. So solution set is negative 5, negative 2, or 0. So you can see example 3 just looks a little bit different. We want to make sure that we're putting factors in order and that we're getting all the terms on one side. So you can see in this one's a little bit different because we have that negative 24y squared on the right hand side, whereas we have the other two terms on the left, and we want them all on one side. So I'm going to put them in descending order with all the terms on one side. So that is going to give me 18y to the third plus 24y squared, because if I change the side, I'm changing the sign, because that would be like adding a 24y squared to both sides, plus the 8y, and because now I have nothing on the right hand side, it's equal to 0. Now you should take a look at this, noticing that you want to factor, and anytime we're factoring, we want to see if we can pull out a greatest common factor first. We can pull out a greatest common factor here. Check in on Ed Puzzle and tell me what that greatest common factor is. So you should have gotten a greatest common factor of 2y, and then that leaves us with the trinomial of 9y squared plus 12y plus 4 equal to 0. Now we, of course, can factor that trinomial further. That trinomial, if you look carefully, perfect square there, square root of 9 is 3, square root of 4 is 2, 3 times 2 is 6, and if I double that, I get 12. So that is a perfect square trinomial. So that factors into 3y plus 2, 3y plus 2. And that brings us to the question down there at the bottom here. I don't have it on this, but that is 2y times 3, the sum of 3y and 2 squared equal to 0. So that's how we're writing the two identical factors. Now we do want to solve this, that's the directions, so we want to set each factor equal to 0. Now with the double factor, the identical factors, we don't have to do that twice. So 2y has to equal 0, or 3y plus 2 has to equal 0. Again, we don't do the 3y plus 2 equal to 0 twice because it would have the same solution. So y is equal to 0, or we have here 3y is equal to negative 2, which gives me y is equal to negative 2/3. And so our solution set, I'm just going to come over here and do the solution set. Our solution set is negative 2/3 and 0. All right, next one's your turn. You do want to pull out a greatest common factor first. We've given you that hint. So go ahead and check that out and pause the video and then check in and see what you got. You should have factored out a 3. That's going to give you x squared minus 5x minus 14 is equal to 0. I can factor that trinomial further. If I look at that trinomial, I see the minus or negative there with the 14. So that tells me that my operations or signs inside are alternating. And I need factors of negative 14 that will add to negative 5. Because that 5 is negative, because that 5 is a negative, then that means that my higher factor should be the negative factor. So my factors of 14, that will have a sum of 5 are 7 and 2, and I want that higher one to be the negative, so I end up with a negative 5 as the inside term. Set those equal to 0, and then I need to solve. Now I don't need to do the 3 as a factor like I did in the previous one with the 2y, because that is a non-variable factor. So obviously 3 can't be equal to 0, so we don't have to worry about that when we're solving. And then x plus 2 is equal to 0, or x minus 7 is equal to 0. And so x is equal to negative 2, or x is equal to 7. And our solution set, negative 2 and 7. All right, then we take this with example 4 a little bit further. You can see that two things here. One, we don't have the trinomial listed, and we have a factor on the other side. So we do want to get all the factors on all the terms on one side of the equation, and then to simplify that, we need to multiply out the factors. All right, it did occur to Miss French and I that, Mrs. Beckley and I, that we did not show you the factoring by matrix method, or foiling method by matrix. So we do want to take a look at that, and I'm going to show you that. You can, of course, just follow FOIL. If there's more terms than that, that can get a little confusing. So I'm just going to quick show you the matrix method. If it's a method that you like, you can follow it. If not, you can just keep doing what you're doing. To do that, you want to look at the fact that there are two terms in each binomial. So you need rows and columns to match your terms in the grid that you're using. So because I have two terms in each, I need 2 rows and 2 columns. Now my first binomial is x minus 1, so I'm just going to put each of those terms in front of a row. And then for the other binomial, I'm going to put each of those terms on the top of a column. So I have x plus 3. Then in order to do that, you're kind of just following, it's almost like a multiplication chart where you do x times x, that gives you x squared. And then when you have x times 3, that gives you 3x. So just kind of looking at that as a matrix to follow. And then when you have x times -1, that gives you -1x. And you have 3 times -1, which gives you -3. And then you just would put your terms, your like terms, together. So hopefully recognizing that you have like terms between the -1 and the 3x. And so you can kind of write all of those out in your trinomial. So we have in those boxes an x squared, and the 3x plus -1x gives you a 2x. And then we have -3. And so that's just another way to FOIL, or to, do something to do in place of FOIL. And you get equals 12. Now we do want all the terms on one side. So when we go back to that equation, we want to make sure we're moving the 12 over to the other side. Of course, that would be subtracting 12 from both sides. So we get x squared plus 2x minus 15 is equal to 0. And then we want to factor that. And so you're factoring into your double bubble. We have a coefficient of 1 for that first term, so we know it's just x squared. The subtraction or minus for the third term tells us that the signs are alternating, so you want to make 1 plus and 1 minus. And I need factors of -15 that are going to give me a positive 2. That positive 2 tells me that the higher of the two factors is going to be the positive one. So thinking about breaking down 15 into factors that are apart by 2 would be 5 and 3. And because that center term is positive, I need that to be 5, and then the -3 there. Then I need to set each of those equal to 0. So either x plus 5 is equal to 0, or x minus 3 is equal to 0. And so x is equal to -5, or x is equal to 3, and then I do my solution set of -5 and 3. Please remember to bring any questions you have into your algebra class, and if you like that matrix method, let us know, and we can take a look at it in class as well. Thanks a lot.